How many hours of sleep would we need on each of the planets in the solar system? In some space travel films, it's shown that the trips are so long that most of the time the crew spends sleeping, or rather hibernating, so as to not spend energy while they arrive at their destination. But in real life, is it possible to hibernate for so long? And if possible, how many hours would we need to sleep on each planet? Get ready to find out. Before embarking on our journey through each of the solar system planets, we must clarify a doubt. Why do we need to sleep? Sleep is a basic need of all animals. In the case of humans, we need to sleep at least 8 hours each terrestrial day. However, not all animals sleep the same number of hours. For example, a sloth bear can sleep up to 20 hours a day. A grizzly bear can hibernate for 200 long days, and ants sleep only a few seconds every so often. Each animal sleeps a certain amount of time that adjusts to its needs and the environment in which it has developed. We humans need to sleep only 8 hours, since we are diurnal animals. That is, we take advantage of the sunlight to perform our activities and sleep during the night. That's why we're not able to see anything in the dark, because our eyes are suitable to see in the day, not at night. That said, let's begin our journey through the solar system's planets. Mercury. We begin our journey on Mercury, the planet's most minor and the closest to the Sun. Mercury is a planet with very extreme climatic conditions. Its temperature varies greatly and depends directly on how much sunlight it receives. For example, the areas that are under the sun's rays can reach 430 degrees Celsius, while the areas that are in the shade or at night have temperatures of minus 180 degrees Celsius. Because of this, if we wanted to spend a relaxing holiday on Mercury, we would necessarily have to do it underground. It is likely that in the future, when humanity has colonized the solar system, due to the extreme conditions of the Mercury surface, we will need to build shelters underground, just as some insects such as ants do. In this case, we would enjoy an unparalleled sunset, where the sun seems to never set, since in Mercury a day lasts 58 Earth days. This abrupt change in the length of days would cause the human race to adapt to the new environment after a long time, and our biological clock would change drastically. After many generations, humans living on Mercury would no longer need to sleep just 8 hours like here on Earth, but about a whole month. Obviously, in this video, we are considering the number of hours of sleep, assuming that in the future, when we have colonized the entire solar system, the human race adapts its biological clock to the solar day of each planet. It's also necessary to consider that the hours of sleep depend on each planet's gravity. The more significant the difference in gravity with the Earth, the more difficult it will be to adapt to the planet, and therefore more hours of sleep will be needed. In this way, if on Earth we sleep only 8 hours in a 24-hour day, on Mercury, a planet whose solar day lasts 58 days and has a gravity lower than the Earth, we would need to sleep approximately 28.5 Earth days. Remember that a solar day is time it takes for each planet to make a complete turn on itself. Venus. We leave behind the minor planet and move on to the hottest planet, Venus. This planet is the most hostile in the solar system. It has an atmosphere with powerful winds and gases lethal to any life form. It is a hell in which no living being could be for a second. Because of this, likely we will not be able to establish bases on the surface of this planet. So if future expeditions are made to this planet, they will probably be for short periods. The way we could visit Venus may be aboard airships. There is a proposal in which we could use Venus's dense and heavy atmosphere to move with airships filled with gas much lighter than the planet's clouds, such as helium or even hydrogen. These airships would be gigantic and would remain floating in the clouds of Venus indefinitely. They wouldn't need engines or propellers, since the same clouds of Venus would always keep them above the lethal, toxic atmosphere for humans. Venus is the planet with the longest day of all. In fact, not only is it the planet with the longest day, but it is the only planet where a day lasts longer than a year. On Venus, a day lasts 243 Earth days, but a year lasts 225 Earth days. In other words, Venus takes longer to make a turn on itself than it does to make a complete turn on the Sun. In one of our past videos, we talked in much more detail about how long a day lasts on each solar planet. We do recommend it. An interesting fact is that the atmosphere of Venus goes around the entire planet in about 4 Earth days. That is, the atmosphere moves much faster than the planet. For that reason, it was previously thought that the days of Venus lasted 4 days, since the photographs we took from Earth only showed the outer clouds of Venus, not its surface. Because of this, if our stay on Venus were in an airship that always keeps floating in the clouds, it would move at the same speed as the clouds. That is, a floating hotel on Venus would take approximately 4 days to circle the planet entirely. In other words, instead of waiting for Venus to turn on itself, we would be the ones who would give a complete turn to the planet in 4 Earth days. Thus, if the human race adapts its biological clock to this cycle, we would need to sleep approximately 30 hours in a row for each turn around Venus. Mars. Things would be much simpler for settlements on the Red Planet, since a day on Mars lasts almost the same as on Earth, 24 hours and 40 minutes. The only problem would be that those who settle on Mars will struggle to adapt to gravity, since it is much weaker on Mars than on Earth. In this way, those who settle on Mars must sleep between 8 and 9 hours for each Martian day. Nothing strange. Do you know any person who already sleeps that amount of hours? Talk to him. Maybe he is an excellent candidate to go to Mars. Jupiter. We arrived at the largest planet of all, the gas giant Jupiter. From here, things will get tough for humans. This planet presents extreme conditions since it is a gaseous planet, which means it does not have a solid surface like the Earth. Jupiter belongs to the gas giants, planets that are made mainly of gas. That is to say, establishing a base on those planets is impossible. The only way we could settle permanently would be similar to the one proposed on Venus, with airships floating on its clouds. Perhaps in the distant future, the human race will develop vast and complex floating space hotels, with airships filled with a very light gas capable of floating on the dense and heavy clouds of the gaseous planets and hosting human beings for an indefinite time. These floating space hotels would be the only way to settle permanently on these surfaceless planets. As in Venus, in Jupiter, the clouds move very fast. Jupiter is the planet with the shortest day of all. A day on Jupiter lasts only 9 hours and 55 minutes. We must also consider that the gravity of Jupiter is overwhelming, so it would be a physical challenge to adapt to extend stays on that planet without suffering irreversible damage to our bodies. At the very least, the effort to adapt would be rewarded with the beautiful views we would have of the tornadoes and hurricanes that would pass under the floating hotel, as well as the incredible views of all the moons on the planet that would rise one after another on the horizon of the night sky. If after many centuries the human race adapts to Jupiter's crushing gravity and short days, they would only need to sleep 2 hours a day because the days last just under 10 hours. Jupiter also has very important moons such as Ganymede, Europa, or Callisto. On these moons, it would also be possible to establish human bases. In fact, it would be much easier to establish them on the natural satellites of the gaseous planets than on the planet. Would you like to know how long we would need to sleep on the most important moons of each gaseous planet? Then give a like to this video, ring the notification bell, and leave us your valuable comment so we know if you would like us to make that video. Saturn. Saturn, like Jupiter, is characterized by being a gas giant. Only this one does not have such strong gravity, and it would not cost us so much work to adapt. As in Jupiter, in Saturn, the days are also very short, lasting only 10 hours and 33 minutes. Because of this, as your common sense tells you, the number of hours we would have to sleep on Saturn would be very similar to the number of hours we should rest on Jupiter, between 2 and 3 hours approximately. On Saturn, things would be quieter because the winds are not as strong as on Jupiter, and the views we would have of the asteroid rings would be impressive, something unique and wonderful throughout the solar system. Uranus. Approaching the limits of the solar system, we reach Uranus, the most inclined planet of all. Here something extraordinary would happen. and that is that this planet has an axis of inclination of 91 degrees concerning the rest of the planets. That is to say that if we looked at the solar system from the North Pole, it would seem that Uranus is lying down. This phenomenon would cause a floating hotel on the clouds of the planet would not present changes in its days and nights for years. This is because when the solstices of Uranus approach, one pole looks continuously in the direction of the sun, while the other is in the opposite direction. Only a narrow band around the equator experiences a rapid day and night cycle, but with the sun very low above the horizon as in the Earth's polar regions. This causes each pole of Uranus to receive about 42 years of uninterrupted sunlight, followed by 42 years of darkness, approximately 84 years to watch a sun rise and sun set. Unlike the rest of the planets, where the days and nights pass with some regularity, in Neptune our biological clock could not adapt to the planet's cycles, since its cycles last longer than human life. For all of this, it is most likely that if in the future the human race manages to establish itself on this planet, as on the others, our sleep cycles will adjust concerning that of the Earth. In other words, on Uranus, we would sleep precisely the same hours that we slept on Earth, about 8 hours. Neptune. We arrive at the last planet in the solar system, Neptune, the blue planet. Like the other gaseous planets, on Neptune we would also be established in floating bases. On this planet, a day lasts 16 hours. If the human race adapts its biological clock with time, it would be enough for us to sleep between 4 and 5 hours for each day of Neptune. On this planet, there is only one factor that could spoil all this. Neptune has the most intense winds in the entire solar system, with gusts reaching 2,000 kilometers per hour. If one of the floating bases were hit by these powerful winds, it would go to pieces, so we would have to find a way to prevent that from happening. What do you think of this tour of the solar system? Would you like to know how many hours of sleep we need on the dwarf planets or the more important moons in the solar system? Let us know your opinion with your valuable comment.